Hi everyone, welcome to today's video on rearranging formulas to isolate variables. So let's start with question 1. We have a plus b equals c and they want us to isolate b. So b is over here and we need to get rid of this positive a. So we can get rid of a positive a by subtracting an a. So if we subtract a from the left side, we must also subtract it from the right side. Because what you do to one side, you must do to the other side in order to keep the value of everything the same. A positive a and a negative a would cancel out, and we'd be left with b equals c minus a. And so now that we've isolated b, we have our answer. In question 2, they're asking us to isolate r. So r is over here, but it's actually a negative r. So first we need to get rid of this positive q. So to get rid of a positive q, we can subtract q from both sides. So subtracting q from the right side will cancel it out. And what we're left with is negative r, because this is a negative r. So negative r equals p minus q. But we want to isolate r, not isolate negative r. So to get rid of this negative sign, because that's essentially the same thing as negative 1 times r, we can divide by negative 1 on both sides. So dividing by negative 1 on both sides, we'd be left with r is equal to, and then p divided by negative 1 would give us a negative p, and then negative q divided by negative 1 would give us a positive q. So what we're left with is r is equal to negative p plus q. Question 3 is asking us to isolate e. So e is over here, and it's being multiplied by 3. So to get rid of being multiplied by 3, we need to divide by 3. So when we do that to the right side, we also need to do that to the left side. So what we're left with now is e is equal to d over 3. Question 4 is asking us to isolate h. So h is over here. We want to get rid of this multiplied by 2, but we can't divide by 2 just yet because we have to divide that whole side by 2. And that makes our g a bit more messy. So what we want to do first is get rid of this g. So this is a positive g, so to get rid of that, we can subtract g from both sides. It would cancel out with the positive g on the right side, and we'd be left with 2h is equal to f minus g. Now we can divide by 2 to get rid of that 2 over here, and what we do to the left side, we must also do to the right side. So this cancels over here, and we're left with h is equal to f minus g over 2. Question 5 is asking us to isolate k. So to isolate k, which is over here, we must first get rid of this negative l, because if we have to divide by 5 right now, that makes our l a bit messy. So to get rid of a negative l, we need to add l. So we're going to add l, and what we do to the right side, we must also do to the left side. So we're going to add l on the left side as well. So now these will cancel, and what we're left with is j plus l equals 5k. Now we can divide by 5 on both sides. The 5s would cancel over here, leaving our k isolated, and what we're left with is k is equal to j plus l over 5. For question 6, they want us to isolate n, which is a part of this term over here. So to get it isolated, we want to remove this term first. So to remove this positive 4, we need to subtract 4 from both sides. This would now cancel, and what we're left with is m minus 4 equals n over 2. Now we can get rid of this dividing by 2 by multiplying both sides by 2. So we can multiply by 2 on this side and multiply by 2 on this side. And now this would cancel, and we're left with n is equal to 2 times m minus 4. And if you wanted to, you could expand and get n is equal to 2m minus 8. Question 7 wants us to isolate q, which is on top over here. So to get q by itself, we need to get rid of this dividing by r. So to get rid of a dividing by r, we need to do the opposite, which is multiplying by r. So we're going to multiply by r on the right side, which means we also have to multiply by r on the left side. So now those would cancel, and we're left with q is equal to r times p. Question 8 wants us to isolate b, which is on the top over here. We can't subtract the c yet because this is not really c. It's c being divided by d as well. And this is not really b, it's b being divided by d also. So the common denominator is d, and we need to get rid of that d. So to do that, we need to multiply by d. So what we do to one side, we also need to do to the other side. Now these d's will cancel, and we're left with d times a is equal to b plus c. Now we can get rid of this c confidently because it's just a c. And so to get rid of it, we just need to subtract c from both sides. So what we're left with is b is equal to d times a minus c. Question 9 wants us to isolate f, which is at the top here. So the first thing we need to do is get rid of this dividing by 3, because this dividing by 3 is dividing the 2f by 3 and also the g by 3. So it's best to get rid of it first. So to get rid of a dividing by 3, we need to multiply by 3 on both sides. It would cancel over here, and what we're left with is 3e equals 2f plus g. Now f is a part of this term, not this term on the right. So we can get rid of the term on the right by subtracting g. Now what we do to one side, we also must do to the other side. So now these would cancel, and we're left with 2f equals 3e minus g. Now to get f by itself, we can get rid of this 2 by dividing by 2 on both sides. And that would leave us with f is equal to 3e minus g divided by 2. Question 10 wants us to isolate s, which is a part of this term over here. So to get it by itself, we want to get rid of this term, which is the r. So to get rid of a positive r, we need to subtract r from both sides. That would cancel here, and we subtract an r over here. Now we have 3s equals 5t minus r. So to get rid of this multiplying by 3, we need to divide by 3. So dividing by 3 on both sides gives us our answer. S is equal to 5t minus r divided by 3. Question 11 wants us to isolate q. So q is over here, but it's being squared. So we need to take the square root of q. And what we do to one side, we must do to the other side. So if we take the square root of q squared, we also need to take the square root of p. So the squared would cancel out with the square root for the q, and we'd be left with q is equal to square root of p. But we need to put this positive and negative sign here to account for both the positive and negative square root of p. That is because both the positive and negative versions of root p will give us q squared when you square it. So let's look at this with an example. So I'm going to write the same equation, but instead of p, I'm going to write 9. So we have 9 equals q squared. So to solve for q, we would just take the square root of both sides. This would cancel, and we'd end up with the square root of 9, which is 3. And we have to include the plus and minus to account for both the positive and negative versions, and that would equal q. Now that we know that q is equal to plus or minus 3, we can plug that back into our original equation to see if it's true. So p is equal to q squared, but instead of q, remember we have plus 3 and we also have a minus 3 version. So we can do p is equal to 3 squared, or p is equal to negative 3 squared. And as you know, 3 times 3 makes 9. And negative 3 times negative 3 also makes 9. So both of these are correct. And that is why when you take the square root of a number, you always have to include the plus and minus sign to account for both the positive and negative versions of that number. Question 12 wants us to isolate b. So b is to the power of 3 here. So to isolate it, we need to take the cube root of b. So if we're taking the cube root of b, we also need to take the cube root of a. So this would cancel here, and we end up with b is equal to the cube root of a. Now earlier you saw we had to include a plus minus, but we don't do that when we have a cubed root, because the cubed root of a positive number will always yield a positive answer, whereas the cube root of a negative number will always yield a negative number. So there's only one answer when you cubed root. And actually that is true for any odd number root. So a 5 root or a 7 root, you don't have to include the plus minus. But when you do an even number root, so like a square root or a 4 root or a 6 root, you always need to include that plus minus in your answer. Question 16 is asking us to isolate a, and for that we can use cross multiplication because we have a proportion. So I'm going to write a times d is equal to b times c. And now to get a by itself, it's being multiplied by d, so we need to divide by d on both sides. And so we get A is equal to B times C divided by D. Here they want us to isolate A again, but this time we're adding. So when we're adding, we need a common denominator. So we have a B here and a D here. So a common denominator between these two would be B times D. So to get that for this fraction, we need to multiply by D over D. And to get that for this fraction, we need to multiply by B over B. And when we do that, we get dA over dB plus CB over dB is equal to E. And since these have the same denominator, you can actually just write it all over one fraction. So now to get rid of this dividing by dB, we just have to multiply both sides by dB. So in doing that, this cancels out here, and we end up with dA plus CB is equal to dBE. Now the A is what we're isolating, and it's a part of this term, not this term, so we can subtract the CB. So subtracting CB from the left side would cancel it out, and subtracting CB from the right side would leave us with this. Now we have dA is equal to dBE minus CB. So to get rid of the D here, which is being multiplied with A, we need to divide by D. So what we do to one side, we must do to the other side. So now that cancels, and what we're left with is A equals dBE minus CB over D. Question 18 wants us to isolate n, which is over here. So what I'm going to do is multiply both sides by m plus n over p to get rid of this in the denominator. So we get m plus n over p times k is equal to L. And now everything here is being multiplied by k, so we need to get rid of that k. So we're going to divide both sides by k. So dividing this side by k and that side by k, this cancels out, and we're left with m plus n over p equals L over k. So n is a part of this term over here, not this term. So we can subtract the m to get rid of it. So that would cancel here, and we'd end up with a minus m over here. And now lastly, we have n over p equals all of this. So to get rid of this dividing by p, we need to multiply both sides by p. So if we were to multiply both sides by p, it would cancel here, and we'd get everything here times p. So our answer then would be n equals p times L over k minus m. Question 19 wants us to isolate r, which is here. So first, what we have to do is get rid of this square root symbol, which is on top of the entire thing. So to do that, we need to square both sides. So what we get is q squared equals r plus s. Now to get rid of this positive s, we need to subtract s from both sides. So when we do that, we get q squared minus s equals r. So that would be our answer. And now lastly, they want us to isolate z, so we have x equals y times the square root of z. So y is being multiplied by this root z. So the first thing we want to do is get rid of this y. So to get rid of a multiplying by y, we need to divide by y. And what we do to one side, we must do to the other. This now cancels, and what we get is root z is equal to x over y. And now to get rid of the square root, we need to square this side, and what we do to one side, we must do to the other side. So we get z is equal to x over y squared, which is the same thing as x squared over y squared. So that would be our final answer. Once again, I'd like to thank you guys for watching. Let me know what kind of videos you want to see in the comments, and I will see you soon in the next video.